This is Geometry B, Unit 6, Surface Area and Volume, Lesson 3, Surface Areas of Pyramids and Cones. Last time we dealt with prisms and cylinders. This is kind of an analog to that. And let's define our terms a little bit here. We have some sort of base that is repeated or pulled through space. That is a prism. And it has some measurements. We can have the V, the area of the base. We can have height, the height of the prism. And we can have P, the perimeter of the base. And we recall the surface area of that is 2 times the area of the base plus the perimeter times the height. Okay? For a pyramid, you start with a base. It can literally be just about any shape. But instead of being pulled through space, it comes to a point. Okay, and that is a pyramid. Okay, and we can think of the surface area of a pyramid as the base plus the lateral area. Well, plus the lateral area, we'll call it LA. Lateral area. Okay. Now, the lateral area can be a little tricky, and it depends on what we're talking about. For the most part, we're going to be dealing with rectangular prisms, or rectangular pyramids. And we'll come back to that here. But the surface area of a pyramid is one base, not 2 bases, plus the lateral area, or the area of the sides here. Okay. We also defined a cylinder as a circle pulled through space. Okay. In which we have the area of the base is a circle with radius r. So area of the base is pi r squared. And the lateral area is the circumference of the circle, which is 2 pi r times the height. And so the surface area of a cylinder is 2 times pi r squared plus 2 plus, I keep putting equals, plus 2 pi r times the height, h. Okay? For a cone, it's similar to a cylinder here, or for a pyramid. It's going to come to a point instead of being having 2 bases. It's just one base. So the base is pi r squared. And then the lateral area is actually, if this is the slant height, we'll call it L, the slant height, L, is pi r L. Pi r L. So the surface area of a cone is pi r squared plus pi r L. Okay, and let's work through a couple of examples here. Okay, I'm going to do a square-based pyramid, and I'm going to do the surface area of a cone. Okay, so let's be efficient here because that's a lot of material to get through. So let's go to grab a new screen here. Okay, and let's talk about a square-based pyramid. Now I'm going to draw the pyramid right side up. Okay, and let's say it's got a length of the base here of 2, 4, 6, 7. Length of the base of 7. Okay, then I'm going to draw the hidden dimensions as well. And a width, let's say it has a width of 5. Actually, no, let's make it 7. I want to keep it simple here. So 7 by 7. So it's a square base. Okay, and I'm drawing it in perspective here. So it comes up 2, 4, 6, 8, 9. So 2, 4, and a half. Okay, so the center's right here. Let's draw straight up from the center. And make the height right here. Okay. So hidden dimensions here. Half the fun of this is drawing. Okay. And so we have a square-based pyramid, and we want to find the surface area of the square-based pyramid. Okay. So, and the height here appears to be 1, 2, 3, 4, 5. I'm going to make it 6. I think I actually drew it 6.5, but let's make it 6. Okay, so it's a 7 by 7 by 6 pyramid. 7 by 7 base, 6 units tall. Okay, we want to find the surface area. So the surface area is the area of the base, which is 7 times 7, plus the lateral height. Now the lateral height is made up of triangles, and there are 4 of them. And let me just sketch one of them here. So there's these triangles that are 7 across the base, but I don't know how tall the triangle is. We'll call it A for apothem here. Okay? But I can find it using right triangles. Right here. If I draw the line connecting the midpoint to the midpoint of the side, we see here a right triangle right here. Actually, let's just sketch it here. Right triangle. Okay? And we can know some of the dimensions. We know this side is 6. We know this side is half of 7, or 3.5. Okay? Half of 7, or 3.5. And the Pythagorean theorem can help us to find the apothem, the height, the slant height, we call it. Okay? Because a squared equals 6 squared plus 3.5 squared. Okay? Or a is the square root of 6 squared plus 3.5 squared. Now I know you might be tempted to work out what numbers those come to. I'm going to leave it just like that for now. So that's the slant height. That's the height of our triangle. And the area of a triangle here, the area of a triangle is 1/2 base times height. 1/2 7 times the slant height. Square root 6 squared plus 3.5 squared. Okay? And so there's what we multiply 4 by. There's 4 triangles. 4 times 1/2 times 7 times square root of 6 squared plus 3.5 squared. And here comes the reason why I left it all alone without working out the numbers here, because we can actually use Desmos to enter all of that at once. Save ourselves some work here. Okay, so our surface area is 7 times 7 plus 4 times 1/2 times 7 times square root, SQRT, 6 squared plus 3.5 squared. Okay, and double check and make sure we entered it correctly. I get a surface area of 146.2. 146.2 square units. Okay, so yeah, these can get a little complicated, but remembering the Pythagorean theorem to find the slant height is probably the trickiest part of it. Okay, all right, let's do another one. This time we're going to do a cone. Okay, a cone. So a cone here, let's grab or draw it. We'll draw it upside down here. Here's the center of the cone. It has a radius of 5. Okay, and it's going to have a height of 2 4. Height of 4. Okay, and we're going to draw the slant height, which we will call L. Now once again, we don't know what the slant height is, but I know the radius is 5 and the height is 4, and there once again is a right triangle. So L squared is 4 squared plus 5 squared. So L, the slant height, is square root of 4 squared plus 5 squared. Okay, and I'm just going to leave that like that here for the sake of time. And so now our surface area becomes the base, pi r squared, plus the slant height, or plus the lateral area, which is pi r L. So let's plug in what we know. Surface area is pi times 5 squared plus 5 times, or plus pi, times the radius of 5 times the square root of 4 squared plus 5 squared, square root. Okay, and once again we can plug that in. Sometimes you're asked to leave it in terms of pi. If that's the case, then we leave it like this. 5 squared is 25. Okay, 4 squared is 16. 5 squared is 25. 16 plus 25 is 41. 16 plus 25 is 16 plus 25 is 30. 41. Yep. Okay. So plus pi times 5. 5 times square root 41 pi. Okay. And we can factor out a pi if you want, but it really doesn't help much. Pi times, or we can put it at the end, 25 plus 5 root 41 pi. Or you can use a calculator to calculate it out. Desmos, oh Desmos. Okay. And let's just enter the original expression here. Pi times 5 squared plus pi times 5 times square root 4 squared plus 5 squared is 179.1 square units. Okay, and that's the surface area of a cone.